Hello everyone, how are you all? I am back again with a lecture on matrices and determinant. So today we will be starting up with the previous year question of JEE Mains as promised. Okay, so with this I will start with the practice questions from JEE Mains previous year questions, and in today's lecture I will discuss the most important top 10 JEE Mains questions. Okay, so I hope you will appreciate these particular lectures and you will take benefit of them. जैसे कि मैंने प्रॉमिस किया था कि विद द एंड ऑफ द चैप्टर यू हैव टू स्टार्ट प्रैक्टिसिंग द क्वेश्चन. सो द बेस्ट वे टू प्रैक्टिस क्वेश्चन इज टू स्टार्ट सॉल्विंग द प्रीवियस ईयर क्वेश्चन. प्रीवियस ईयर क्वेश्चन करने के बाद पता है क्या होने वाला है? एक तो कॉन्फिडेंस बहुत ज़्यादा बढ़ने वाला है. It will boost your confidence. Simultaneously you will also have a good hand on experience कि एग्जाम में कैसे क्वेश्चन आते हैं और उस क्वेश्चन को कैसे टैकल किया जाता है. ठीक है, सो इन टूडेज लेक्चर आई विल स्टार्ट एंड सॉल्विंग ऑन द टॉप 10 questions of JEE Mains previous year question, and simultaneously I will give one homework question, that is a bonus problem to all of you. You try to solve that particular question and give me the answer in the comment section. Okay, so with this let us start with the today's lecture. Also the question bank for JEE Mains previous year question can be found in the description box. Go check out for the link in the description. So with this I will also provide the short notes for the chapter of matrices and determinant in the upcoming lectures, and I hope you will appreciate my content and like it. Okay, so and let's get started. Okay, so this is basically about me. If you're knowing me, well and good. If not, then you can read this particular slide. Okay, now let us start with today's goal, that is basically we will start with solving the previous year questions of JEE Mains. Now the previous year question which I actually took is basically of the year 2023 and 2022 in combined. Okay, now basically I took the top 2000 questions which I felt which is most important. Now in the upcoming lectures there will be many some sessions where I will be continuing with the previous year questions also on the chapter of matrices and determinant. Unless and until I feel that the chapter is totally completed from my side, I won't leave this particular playlist of matrices and determinant. So with this let's get started, and with this we have the first question on the screen. So I hope you will pause this particular question or pause the video and take a screenshot and try this particular question on your own and come back to the lecture to match the answer. So okay, so let me get started and try to solve this particular and read this question, what the question says. Now in this given question it says that there is a given system of equations. Okay, ना जैसे कि मैंने बताया था कि सिस्टम ऑफ इक्वेशन में काफ़ी ज़्यादा क्वेश्चन आ रखा है. इन द प्रीवियस क्वेश्चन उठा के देखोगे ना, बहुत ज़्यादा सिस्टम ऑफ लीनियर साइमल्टेनियस लीनियर क्वेश्चन का क्वेश्चन मिलेगा. तो बेसिकली क्या बोल रहा है कि 3 वेरिएबल्स एंड 3 इक्वेशंस आर गिवन, एंड सच 3 वेरिएबल 3 इक्वेशंस इज बेसिकली हैज़ इनफाइनाइटली मेनी सॉल्यूशन. ओके, हैज़ इनफाइनाइटली many solutions. Okay, has infinitely many solutions. So what does this implies? So from here I can say one conclusion that जो delta का जो determinant होगा that will value is 1, that will value is 0, and simultaneously delta 1, delta 2 and delta 3 का value is 0. If you have followed my lectures, I hope this understanding is basically clear that this delta is basically the determinant of the coefficient matrix. Okay, and delta 1 is formed by replacing the first column with these particular elements, these constant elements, and similar delta 2 is formed by replacing the second column with this particular element, and similar delta 3 is formed by replacing the third column with this particular element. Now simultaneously if we solve these two particular equations, we will get the value of the two unknown, that is lambda and mu from here. So let us try and solve out that value of delta is equal to 0. From here I will get 2, 1, minus 1, 2, minus 5, and lambda and 1, 2 and minus 5 over here. Be very patient to solve and write this particular coefficient matrix as in the same order it is appeared in the question. So while writing the coefficient, you may mistakenly write the coefficient of x in place of y, and then you actually represent the matrix in the same order, but be careful that you represent the corresponding coefficient in the corresponding places. I hope this particular mistake will be taken care of by you students. Okay, so let us equate it to 0. So from here what I get, I try to solve some elementary transformation, and if I try some elementary transformation, what will I get? Now I apply a transformation, that is rho 2 goes to rho 2 minus rho 3, similarly 2 times of rho 3, and similarly rho 1 goes to rho 1 minus 2 times of rho 3. From here if I solve this, I will get 1 over here, 0 over here and 0 over here, and similarly the third row will remain unchanged. Now if I solve, then this will be minus 5 minus of 2 times of that is minus of 9, and similarly 1 minus of 2 times of 2, that is minus of 4, that is minus 3. Now similarly this will be basically delta lambda plus 10, and this will be basically minus 1 minus of 2 times of minus 5, that is basically 10, and 1, this is minus 9. So if I equate it to 0, from here if I expand the determinant, along the first column, and the first column I will get 1 into these particular elements will come up as minus 3 times of lambda plus 10 minus of Now this will be a square bracket, let me put here square bracket, minus of 81. Now if it is equal to 0, now if I cancel from here, if I take 3 common and I write here 27, okay, so from here what will I get? That will be minus of lambda minus of 10, and this will be minus of 27. So if I equate it to 0, then this particular will be the result. Okay, now let me check for the sign mistakes, okay, whether there is a sign mistake or not. So there isn't any sign mistake, okay, or let me check for the calculation over here once again. So if I check from here, this will be minus 1 minus of 2 times of minus of 5, that is plus of 10, this is minus of 9, sorry, this is actually plus of 9, sorry, this is actually plus of 9, this is actually plus of 9, this is actually plus of 9. So from here I will get actually the minus of 9, that is basically plus of 81. So from here I will get plus 21. From here I will get minus of lambda is basically equal to minus 17. So from here lambda का value जो आने वाला है, that is 17. Now if we solve any of this particular coefficient, this delta 1 or delta 2 or delta 3 equal to 0, and if we get the result, then we will get the value of the mu. Let us solve delta 3. There is 2 1 5. This will be basically 2 minus 5. This will be basically 1 2, and this will be basically mu, and this will be basically 7. So I hope this particular thing will be when it is equated to 0. Now let us solve this matrix on the next page. So if we apply the same transformation from here, I will get 1 over here, 0 over here, 17 0 over here, and similarly this particular the third row remains unchanged, that is 2 and 7 over here. Similarly, if I minus 5 minus of 2 times of 4, that is basically equal to minus of 9. Similarly 1 minus of 4, that is minus of 3, and similarly 5 minus 14 is basically equal to minus 9. Similarly over here, if I see this is mu minus of 14, this is mu minus 14, and if I equate it to 0, okay, now let us expand on the first column. So what will I get? The result I will get here, it is minus 3 times of mu minus 14 minus of 81. Okay, now if I solve this, I will get minus 3 mu plus 42 minus of 81 is equal to 0. So from here I will get 3 mu is basically equal to minus of, so 3 mu will basically equal to minus of, this will be 39, and from here I will get mu ka value is minus of 13. If you solve this, this will be minus 39. Okay, so from here I get the value of lambda as well as mu equally. Now what I have to calculate is basically this particular expression, that is lambda plus mu ka whole square plus lambda minus mu ka whole square. Now if I calculate this particular expression, what will I get? Now lambda plus mu, that is basically 17 minus 13 ka whole square plus 17 plus 13 ka whole square. Now from here I will get 30 ka square plus 4 ka square. From here I will get the result as 916. So with this, the right option to this particular question is 916, that is option A. I hope you have solved this particular question and have matched the particular solution correctly. Okay, now let us move on to the next question. The next problem is basically this particular question, which again talks about system of linear equations. Now यहाँ पर भी एक system of linear equation दे रखा है. Now what does the question tries to correlate is basically which of the following option is not correct. अब पता है JEE Mains और JEE Advanced का क्वेश्चन में क्या होता है पता है, बोथ टाइम्स कॉम्पिटेटिव एग्जाम में ना यही देखोगे कि मल्टीपल चॉइस क्वेश्चन में ना पूछ देगा which of the following is not correct. ना नॉट करेक्ट इज द थिंग दैट डजंट, जो लोग उतना सोचते नहीं है, ठीक है, जहाँ पर नॉट करेक्ट लिखा हुआ है अच्छे से फोकस करके क्वेश्चन को पढ़ो ना. बिफोर सॉल्विंग द क्वेश्चन यू शुड डेफिनेटली नाइसली रीड द क्वेश्चन, ठीक है. विदाउट रीडिंग द क्वेश्चन यू डोंट मूव ऑन बेसिकली टू डायरेक्टली जंप ऑन टू गेट द सॉल्यूशन, क्योंकि क्वेश्चन में पूछेगा नॉट करेक्ट और करेक्ट मार्क करके आ जाने वाले हो. तो दिस इज बेसिकली कॉमन मिस्टेक दैट इज मोस्टली मेड बाय द स्टूडेंट्स. ओके, और ये टैक्टिक्स होता है एग्जामिनर का कि टू एलिमिनेट द मोस्ट नंबर ऑफ स्टूडेंट्स. ओके, so I hope this particular thing is clear. Now let us try and see if it is trying to say which of the following is not correct. The option says that infinitely many solution for given values of a, b, or unique solution for given values of a and b. Okay, so let us try and solve the firstly. Let us try and calculate the expression of the coefficient matrix, that is delta. So from here I will get to the important relations. Okay, so let us try and solve the delta. So if I solve this delta matrix, the delta determinant, that is 1 2 and 3 over here, and this is 2 minus 5, this is 2 again over here. Now let us calculate this particular expression. Now from here I apply two important element transformation, that is rho 1 goes to rho 1 minus 2 times of rho 2, and similarly rho 3 goes to rho 3 minus 2 times of rho 2. Okay, so with this, if I apply this particular transformation, the rho 2 remains unchanged, this particular element will get 0, this particular will get 0, and similarly 4 minus 4 basically equal to 0. Similarly this will be 2a minus of 6, and simultaneously this element will be minus 5 minus of 4, this will be minus of 9, and similarly this will be 2 minus 6, that is minus of 4. Now if I equate this particular delta, the value of the delta along the first column, so I will get minus 1 multiplied by minus 8 sorry, not minus 8, okay, minus 1 multiplied by 0 minus of 9 times of minus 9, that is plus of 9 times of 2a minus 6 is equal to some delta, this delta. Now from here if I take 2 common out from here, that is 18 times of a minus 3, which is the value of delta. ना आपको पता होगा अगर डेल्टा का वैल्यू जीरो हो देन देयर माइट बी अ केसेस जहाँ पर इन्फिनिटली सॉल्यूशन आ सकता है या फिर नो सॉल्यूशन आ सकता है, बट जो क्वेश्चन में ऑप्शन दे रखा है वहाँ पर नो सॉल्यूशन कोई बात ही नहीं कर रहा है. दैट मीन्स डेल्टा अगर जीरो हो जाता है, दैट मीन्स देयर कैन बी केसेस ऑफ वेयर इन्फिनिट सॉल्यूशन मेट एग्जिस्ट. सो इफ ए का वैल्यू इज इक्वल टू 3 देन देयर कैन बी नो केसेस वेयर द इट हैज़ यूनिक वैल्यूज तो हो ही नहीं सकता अगर ए का वैल्यू 3 हो. दैट मीन्स ए का वैल्यू अगर 3 हो, दैट मीन्स इट विल हैव इन्फिनिट सॉल्यूशन. It will have infinite solution. It will have how many? It will have infinite solution, because if the question mentions like this, or may have no solution. Now let us move further and solve this any one of the delta 1, delta 2 and delta 3. So if I try and solve the delta 3 matrix, okay, let us try it and solve the delta 3 determinant. So from here if I solve the delta 3 determinant, that will basically be 1, 2, 4, this is 2 minus of 5, and this will be b, this will be 4, this will be 8. And if I solve this particular determinant, if I solve the determinant value of delta 3, now with the same transformation that I actually applied in the first case, that is rho 1 minus 2 times of rho 2, and similarly rho 3 goes to rho 3 minus 2 times of rho 2. So if I will solve this, I will get this particular 0, and this is of 0, this will be 2, this will be 4 over here, and if I solve this particular element will get 0 and minus 9, and this particular element will be b minus of 8, and similarly this element will be 8 minus 8, that is again 0. Now if I solve this determinant value, so if I solve along the first column, I will get the value as 0 minus of 9 times of b minus 8. Okay, so from here what I get the result as, if delta 3 is basically equal to minus 9 times of b minus 8. Okay, so from here also a negative time is given over here. Okay, alright, so from here what I see, if delta 3 is value is b minus 8. Now from here if delta 3 value is 0, that means, and delta is also 0, and if all the values are, and simultaneously if b is equal to 8, the delta 3 value is 0. अगर डेल्टा 3 का वैल्यू 0 है, दैट मीन्स व्हाट डज इज इम्प्लाइज, दैट मीन्स डेल्टा 1 डेल्टा 2 विल ऑल्सो गेट 0. अगर b का वैल्यू मैं 8 ले लूँ, एंड इफ यू सॉल्व द डेल्टा 1, डेल्टा 2 एंड डेल्टा 3, यू विल साइमल्टेनियसली गेट द रिजल्ट एज नथिंग बट 0. एंड इन दैट पर्टिकुलर केस व्हाट इज द नंबर ऑफ व्हाट सॉल्यूशन विल गेट, यू विल गेट इनफाइनाइटली मेनी सॉल्यूशन. If you get infinite solution, if b is equal to 8 and a is equal to 3, then you get infinitely many solution. Now in this question, if you largely look on this particular option, if you look at option B, it says if you have infinitely many solution, if a is 3 and b is 8, this particular right option, this is actually correct statement, this is true. Now if I read the second question, it has infinitely many solution, if a is equal to 3 but b is equal to 6, is it true? No, this is actually false statement. So with this, and we also already know that JEE Mains question जो एक single correct question है, so with this I got the second option as the correct answer to this correct option. So I hope this option B is actually the clear. Similarly, if I go on and read this, a has unique value if a is equal to b is equal to 8, it is very true. It is also true because अगर डेल्टा 3 का वैल्यू 0 हो बट डेल्टा इज नॉट इक्वल टू 0, देन इट हैज़ यूनिक सॉल्यूशन. दैट मीन्स z का वैल्यू 0 हो सकता है, z का वैल्यू 0 होगा ओके एंड हो सकता है कि डेल्टा 1 डेल्टा 2 भी 0 हो जाए साइमल्टेनियसली, हो ही सकता है, बट दैट डजंट काउंट इन इनफाइनाइट मेनी, दैट हैज यूनिक सॉल्यूशन। सिमिलरली अगर ए और बी का वैल्यू दोनों ही 6 हो जाए, दैट मीन्स ऑल्सो एन यूनिक सॉल्यूशन, दैट इज ऑल्सो ट्रू स्टेटमेंट। So this is not the right answer, this is also not the right answer, this is also not the right answer, because the question says choose the not correct answer. Okay, so which of the following is not incorrect option, which of the following is incorrect option. So from here I get the incorrect option as option number B. I hope this particular solution is clear. If not clear, please rewind the video and once again and try to solve it on your own. Try to correlate with this particular solution with that particular flowchart that I have already talked about in the lecture number 3 of determinants. Okay, when I was talking about solution of simultaneous linear equation. Okay, let us move on to solve the third question that says, okay, let us read this particular question. So what I see from this particular question, it says the number of symmetric matrices which is of order 3 cross 3. ना सिमेट्रिक मैट्रिक्स ऑफ ऑर्डर मतलब 3 बोल रखा है, अगर सिमेट्रिक मैट्रिक्स बोला, सिमेट्रिक मैट्रिक्स ऑलवेज स्क्वायर मैट्रिक्स ऑर्डर है 3 मतलब 3 क्रॉस 3 का मैट्रिक्स है। तो लेट अस ट्राई टू मेक अ सिमेट्रिक मैट्रिक्स व्हिच इज ऑफ ऑर्डर 3 क्रॉस 3. Now what we know 3 symmetric matrix. So what symmetric matrix is basically such a matrix in which if you take the transpose you get the same matrix. You get the same matrix. That means the elements Aij is basically equal to Aji. This particular element set is same. Okay, now if I write these elements as terms of any unknown values, that is A, B, C as a diagonal element, if I write D, E and F over here, similarly to this particular diagonal element, this particular element will be D, and to this particular element will be E, to this particular element will be F. As in this fashion what I see that only the unique values are these particular values. Unique values are these, basically these values. So if I try and calculate total unique values present, if I see total unique values, what I see, along the diagonal element there are 3 values, along this particular element there are 2 values, along this particular element there is 1 values, and if I add them that is basically 1 plus 2 plus 3, and if I see this is 6 number of values which are unique, and all the elements can be filled by the numbers, that is 0, 1, 2 and up to 9. So that means this makes up 10 elements. So these 6 particular positions which are unique positions, these 6 unique positions can be filled in how many ways? That is 6 ways, that is 10 ways, sorry. So if I ask the total number of symmetric matrix possible, if I ask total symmetric matrix possible, then what will you say? That the 6 unique position can be filled in 10 ways. So if I multiply 6 unique position in 10 ways, that will basically is 6 times, it is multiplied, 10 is multiplied 6 times. So from here I will get the result, that is 10 to the power 6. So with this we get to the come to the correct option, that is option number C. So I hope this particular solution is clear. So from here I will try to write an important note. Okay, I will give you an important note. Okay, so you can write this note particular over here. If the elements can be a real number, if the elements of the symmetric matrix can be real number, and if the symmetric matrix is of order that is n, and this particular symmetric matrix, okay, and I am talking of symmetric matrix, okay, symmetric matrix, that is A of ij is basically equal to A of ji, that means A transpose is basically equal to A. So if I am talking of symmetric matrix of order n, then I can say the total number of symmetric matrix possible, total symmetric matrix possible where all the elements are real numbers, is basically equal to n into n plus 1 by 2. And how this formula comes, if I take an n cross n symmetric matrix, so what I see, the unique elements, so if I take this n cross n symmetric n cross n elements, okay, and this particular thing is a1, and let us represent it as a2, and this is a of n. Similarly the unique elements actually occur like this. So here over in the diagonal elements there are all elements are unique. So from here I will get n elements. Similarly above this diagonal element I will get n minus 1 number of unique elements. So from here I will get n minus 2 times of unique element, and simultaneously if I go on and so on I will get 1 number of unique element at the last. So if I sum up all these particular element, there is basically the sum of all the first n natural numbers. So from here I will get the sum of first n natural numbers, n plus n minus 1 plus n minus 2 and so on up to 1. So this particular result is related as n into n plus 1 divided by 2. So this is the total number of symmetric matrix that is possible. I hope this particular explanation is clear. Okay, I hope this particular explanation is clear. Okay, now with this let us move on to the another important question. Now star mark करके रखो, ये वाला क्वेश्चन जो है ना, you have to star mark this question. Now अगर JEE Mains ऐसा लेवल का क्वेश्चन पूछ रहा है, अगर JEE Mains इस लेवल का क्वेश्चन पूछ रहा है, दैट मीन्स यू हैव टू बी वेरी लाइक गुड प्रॉब्लम सॉल्वर. ये क्वेश्चन अच्छा क्वेश्चन है. ओके, नाउ दिस क्वेश्चन इज बेसिकली टॉक्स अबाउट प्रोबेबिलिटी, टॉक्स अबाउट मैट्रिक्स, टॉक्स अबाउट परम्यूटेशन एंड कॉम्बिनेशन. ना मैट्रिक्स का जो कॉन्सेप्ट है ना, ये सिर्फ इतना ही है कि इन्वर्टिबल मैट्रिक्स. अब इन्वर्टिबल मैट्रिक्स कब होता है? जब व्हेन द डिटर्मिनेंट ऑफ द वैल्यू इज नॉन जीरो. ना क्वेश्चन में क्या बोला है? देयर इज अ सैम्पल स्पेस, देयर इज अ सैम्पल स्पेस विच इज ऑफ मैट्रिक्स, देयर इज अ 2x2 मैट्रिक्स इज गिवन. A 2x2 matrix is given. Now how do you understand this is a 2x2 matrix with all the elements which are ranging from 0, 1 and 2, which can be filled with elements 0, 1 and 2. Now how do you understand that this particular matrix is actually 2x2? Now from this particular result what I see, the I का जो value है that is less than or equal to 2 but greater than or equal to 1. Similarly J का जो value है that is greater than or equal to 2, similarly less than 1. So from here this particular condition is a way of representing matrix of order 2x2. दिस इज अ वे बिकॉज आई का वैल्यू लेस देन, आई का वैल्यू 1 हो सकता है, आई का वैल्यू 2 हो सकता है, आई का वैल्यू जे का वैल्यू 1 हो सकता है, जे का वैल्यू 2 हो सकता है. जे और आई क्या है? बेसिकली एलिमेंट्स ऑफ अ मैट्रिक्स है. तो बेसिकली व्हाट इज द हाईएस्ट आई जे का वैल्यू क्या हो सकता है? दैट इज ए टू टू. और ए टू टू कहाँ पर आता है? अगर स्क्वायर मैट्रिक्स का बात हो रहा है, हाउ डू यू अंडरस्टैंड दिस इज स्क्वायर मैट्रिक्स? ओके, ना हाउ विल आई अंडरस्टैंड दिस पर्टिकुलर स्क्वायर मैट्रिक्स? ना पहला तो एक तो हिंट ऐसे लग सकता है कि इन्वर्टिबल मैट्रिक्स का बात पूछ रहा है, और इन्वर्टिबल का मैट्रिक्स का बात पूछ रहा है, दैट मीन्स डिटर्मिनेंट इन्वॉल्व होगा. डिटर्मिनेंट किसका कैलकुलेट किया जाता है? स्क्वायर मैट्रिक्स का कैलकुलेट किया जाता है. ना दिस इज ऑल्सो एन इंडिकेशन. और सिमिलरली इफ यू कैलकुलेट ऑल दिस एलिमेंट पॉसिबिलिटी, दैट इज यू विल गेट A11, A12 and A21. So from this you can sense that this is particular square matrix, this is particular square matrix of order 2x2. Now the sample space basically talks about, the sample space basically talks about all the possibilities. Now if you see all the possibilities over here, this particular position can be filled in 3 ways. Now this particular position can be filled in 3 ways, this particular position can be filled in 3 ways, and simultaneously this particular position can be filled in 3 ways. So there are 4 positions and each 4 position can be filled in 3 ways. In this way you can say the total number of sample space, that is the total number of sample space, that is the number of S elements, will basically, the number of elements in the set S is basically 3 to the power 4, that is basically 81 elements are possible. Now the catch and the important thing over this in this particular question is basically in solving and getting out the invertible matrix. Okay, now if I solve and try to check what is this is particular, and the event is basically event is basically a matrix which also belongs to set S, and M is invertible. Now M is invertible, that means this matrix M, this determinant of the matrix M is basically non-zero. Now let us calculate. Now how will I get to the result of non-zero? Now for that I will use the principle of inclusion and exclusion. Now for this result I will firstly try to calculate the cases when the value of M is 0. Now when is the value of M is 0? If I consider a 2x2 square matrix, and if I take its determinant value, then you will say this determinant value is basically equal to AD minus BC. Now you know all these particular elements can be filled with this particular number, that is 1, 2 and 0. Now if I calculate what can be the possible values of this particular determinant value, now these particular possible values of this particular determinant can be 0, can be 1, can be 2, can be 4. Okay, now these are basically the possibilities that can be arises. Now similarly if we solve for each possibilities when these particular values can arise. Okay, for example, if we get this result as equal to 0, if the delta value is basically equal to 0, then what I get is basically AD is equal to BC. Now what are possible values of AD and BC is basically equal to 1, 0, 1, 2 and 4. This can be the possible values of AD. This can be possible values of AD as well as possible values of BC. Now if AD and BC are equal and the possible values of this particular thing, now let us check and find what can be the number of cases corresponding to each possible cases, and then in such fashion we will get to the result of the event number of elements in the event matrix in event set. Okay, so with this if we solve, if AD is equal to BC is equal to 0, so from here if we try to get the result, and for this particular result also we will use the principle of inclusion and exclusion. Now what is the total number of possible ways that A can be filled? There is 3 ways. Similarly D can be filled in 3 ways. Now the result should be 0. Now result कब 0 नहीं होगा? कब 0 नहीं होगा? जब A का वैल्यू 1 या 2 से कोई यूज करो, या फिर D का वैल्यू 1 या 2 से कुछ चूज करो, नॉट या फिर A का वैल्यू 1 या 2 से चूज करो एंड देन D का वैल्यू 1 या 2 से चूज करो. और जब भी मैं बता रहा हूँ एंड देन, दैट मीन्स देयर विल बी मल्टीप्लिकेशन इन्वॉल्व्ड. there will be multiplication involved, and this negative sign is basically for the principle of inclusion and exclusion. एक्सक्लूड करना है ना, तो टोटल नंबर ऑफ केसेस कैन भी क्या हो सकता है, यहाँ इस एलिमेंट्स को थ्री वे से फिक्स कर सकते हैं, एंड देन इस वे को इस डी एलिमेंट को थ्री वे से फिक्स कर सकते हैं. सो इफ वी अप्लाई द मल्टीप्लिकेटिव रूल ऑफ काउंटिंग, इफ वी अप्लाई द मल्टीप्लिकेशन रूल ऑफ काउंटिंग, देन दिस 3 into 3 एंड सब्ट्रैक्ट ऑल द एलिमेंट्स विच कॉरस्पॉन्ड, जहाँ पर वैल्यू जीरो हो सकता है, जहाँ पर वैल्यू जीरो नहीं हो सकता है, दैट एंड दिस फैशन विल गेट द वैल्यू जहाँ पर जीरो हो सकता है. अगर मैं टोटल नंबर ऑफ एलिमेंट से, टोटल नंबर ऑफ इवेंट से माइनस कर दूँ वो अनफेवरेबल केसेस, देन वी गेट द फेवरेबल केसेस. टोटल केसेस से अनफेवरेबल केसेस को माइनस करने से फेवरेबल आ जाएगा. तो दैट व्हाट आई एम डूइंग, दैट इज 3 into 3 माइनस कर रहा हूँ on the unfavorable cases, that is 2 into 2, and similarly goes on for B and to C. So if I write for B into C, I will get like this. Okay, now this is basically the condition which related to this particular first case, that is AD and BD BC are basically similar, same and are equal to 0. So इस केस में कितना नंबर ऑफ एलिमेंट्स हो सकता है. So for the first case I get the number of element that is possible is 9 minus 4 into 9 minus 4, that is basically 5 square. There is 25 elements are possible from this particular first case. Now if I try to solve the second case says कि AD और BC का वैल्यू इक्वल हो, और इक्वल हो क्या हो जाए, 1 हो जाए. और 1 कैसे हो सकता है, 1 कैसे हो सकता है ना, द नंबर ऑफ केसेस विच कॉरस्पॉन्ड, ये 1 कब हो सकता है ना, व्हेन ए का वैल्यू 1 हो जाए एंड साइमल्टेनियसली डी का वैल्यू 1 हो जाए. कूल. सिमिलरली बी का वैल्यू 1 हो जाए और सी का वैल्यू भी 1 हो जाए. ओके, सो इन दिस पर्टिकुलर फैशन ऑल्सो वी गेट द रिजल्ट जब वैल्यू क्या हो जाएगा, 1 हो जाएगा ना. कितने नंबर पॉसिबल केसेस हो सकते हैं इसमें, तो अगर आप अच्छे से देखोगे ना तो एक ही केसेस पॉसिबल हो सकता है. ओनली 1 पॉसिबल केस कैन वी गेट फ्रॉम दिस रिजल्ट, क्योंकि डी का वैल्यू 2 नहीं चूज कर सकते हो, डी का वैल्यू 0 नहीं चूज कर सकते हो. इफ ए का वैल्यू अगर 1, मतलब इस टोटल प्रोडक्ट को 1 करना है, वी कैन ओनली डू इट इफ ए का वैल्यू इज 1 एंड डी का वैल्यू इज 1. सो द नंबर ऑफ पॉसिबल केसेस corresponding to this particular case is also 1. Similarly, if we go and solve this third particular case, that is AD is equal to BC is equal to 2. Now in this particular cases we can have two particular solution, that is A का वैल्यू अगर 1 हो जाए तो D का पास में मेरे पास 2 चॉइसेस है, D के पास मेरे पास एक ही चॉइसेस है, D के पास मेरे पास एक ही चॉइसेस है. मैं फिर से बताऊंगा, ठीक है. अगर A का वैल्यू 1 हो जाए, अगर A का वैल्यू इज इक्वल टू 1, देन फॉर दिस पर्टिकुलर केस मेरे पास D का वैल्यू एक ही चॉइस है, दैट इज D को 2 चूज करो, दैट इज 1 रिजल्ट. सिमिलरली अगर A का वैल्यू मैं 2 चूज कर लेता हूँ, अगर A का वैल्यू 2 चूज कर लेता हूँ, देन ऑल्सो दिस इज 1 वे, देयर इज ओनली 1 वे इन फिलिंग B. Now this is 2 ways. Now similar goes to the case of B, this is also 2 ways. Okay, now 2 and 2 ways are the ways in which this particular element can be filled. So यहाँ से number of possible cases can be, this is 4. Okay, because AD can be, AD का वैल्यूज और चूज कर सकते हैं 2 ways में, BC का वैल्यू भी चूज कर सकते हैं 2 ways में. Okay, now similarly if we solve the fourth result, that is AD is equal to BC is basically equal to 4. ना इसके कॉरस्पॉन्डिंग भी आपको एक ही केस मिलेगा, जब A का वैल्यू 2 हो जाए, D का वैल्यू भी 2 हो जाए, B का वैल्यू भी 2 हो जाए, C का वैल्यू 2 हो जाए. दैट मीन्स दिस कॉरस्पॉन्ड टू 1 केस, दिस कॉरस्पॉन्ड टू 1 केस एंड दिस ऑल्सो 1 केस. So from here, if I calculate the value of this number of results in the event matrix, so I will write this particular thing by E. This is the event matrix. Sorry, event set. The number of elements in the event set is basically equal to total number of favorable event minus unfavorable number of events. तो total event कितना था, सबसेट में जितना number of events था, minus number of events in this E dash. I hope this particular thing is clear by the concept of principle of inclusion and exclusion. The total number of samples case कितना था, 81. माइनस कर दूँ, कितना एलिमेंट्स को माइनस कर दो, 25 था वहाँ से, यहाँ से 1 plus 4 that is 6, that is 31. So if I minus 31, I will get the number of elements in the event matrix, so which is 50. Now if I calculate the probability of this given event, this is basically number of elements in the event matrix divided by number of elements in the event set divided by number of elements in the sample space. So if from this I will get the result as 50 by 81. So with this we get to the required probability, that is 50 by 81. So with this we get the right option to this question is basically option number C. Okay, so I hope this particular explanation of the concept is very clear. Now those students who have difficulty in understanding the concept of probability and even understanding the concept of permutation and combination, I will cover up this particular question in the chapter when I will dealing with the chapter of permutation and combination again. So I hope these particular results are very clear. Okay, now these particular results are not clear, then just leave this particular question for the time being. If you are a dropout student, for you this particular question will be very easy. I hope so. Okay. Now let us move on to the fourth question. I guess I didn't count this question. Okay, is basically, okay, this is basically fifth question. Okay, let us move on to the fifth question and solve this. Now this question is also a very good question which I took up. Okay. Okay. Now from this question what I see, now this question clearly mentioned that there is a matrix which is a 2 cross 2 matrix, okay, with a real identities where all the identities are basically real numbers. क्या बोल रखा है ना, एक 2 cross 2 मैट्रिक्स दे रखा है जहाँ पर रियल आइडेंटिटी से फिलअप किया गया है सच दैट ए डैश, अब मैंने आपको पहले से बता रखा है चाहे ए टी देख रखा हुआ, दिस बेसिकली सेम एज ए डैश ऑल्सो, दिस बेसिकली ट्रांसपोज ऑफ अ मैट्रिक्स, दिस बेसिकली टॉकिंग अबाउट ट्रांसपोज, दिस बेसिकली टॉकिंग अबाउट ट्रांसपोज ऑफ अ मैट्रिक्स. ना क्वेश्चन में क्या दे रखा है कि बेसिकली ये मैट्रिक्स इक्वेशन दे रखा है इन्वॉल्विंग ट्रांसपोज, दैट इज ए ट्रांसपोज इज बेसिकली इक्वल टू अल्फा टाइम्स ऑफ ए प्लस आइडेंटिटी मैट्रिक्स. And again you have also provided with the value of alpha is basically real number minus दो नंबर नहीं हो सकता, that is -1 and 1 नहीं हो सकता है. And if you see again there is another condition, that is determinant value of a square minus of a is basically equal to 4. Now there are two conditions which are given in the question. There are two conditions given in the question. Now let us try to understand how to solve this particular question. Now from the first equation, if I try to take transpose on both the side, okay, I will get the result as something which is 8 alpha A transpose plus INT matrix का transpose. We know this particular result कि A plus B का whole का transpose is basically A transpose plus B transpose, and similarly alpha is a constant number, so this can be written as alpha into A transpose plus identity matrix. Identity matrix का transpose also same रहता है क्योंकि the identity matrix the elements only occur on the diagonal and the diagonal element doesn't changes in transpose, and A transpose का transpose is basically equal to A by the properties. And similarly if you go on and solve this, if I see this will be basically alpha, and from A transpose on the first equation I can put this will be alpha plus identity matrix plus identity matrix. Now from here if I solve I will basically get the result as 1 minus of alpha square times of matrix A is basically equal to alpha plus 1 times of identity matrix. Now if I go on and solve this I will get the matrix A is basically equal to 1 plus alpha divided by 1 minus alpha into 1 plus alpha. Now from here I can cancel out 1 plus alpha by 1 plus alpha because alpha is not equal to -1 and alpha is not equal to 1 also. So if alpha is not equal to -1 I can cancel this particular result. So from here I will get the value of the matrix is basically identity divided by some constant, that is 1 minus alpha, that is basically 1 minus of alpha. Okay, so this will be 1 minus alpha. Now again we are given the result, that is determinant of a square minus of a is basically equal to 4. Now if I try from this particular result, if I take a common of this particular determinant, I can write this determinant of a multiplied by determinant of a minus identity matrix, which is equal to 4. Now if I solve a minus identity matrix, I will get identity minus of identity divided by 1 minus alpha minus of identity matrix. So if I take identity from here common, then I will get the result is 1 minus 1 by alpha minus of 1. So from here I will get the result as, if I solve this I will get the result as 1 minus alpha नीचे आने वाला है 1 minus of and 1 cancel and alpha times of identity matrix आने वाला है. This is basically the value of 1 minus identity matrix. And if I take the determinant value of this particular thing, this particular value will be basically equal to alpha by 1 minus alpha का whole square and alpha का whole square. Because we know if scalar number is taken common out from our matrix and in from our determinant, then it get multiplied in raised to the power of the order of the matrix. Now from here if I solve this I will get the determinant value of matrix A is basically equal to 1 minus alpha ka whole square and into alpha square by 1 minus alpha ka whole square, which is equal to 4. So from here if I solve this alpha square by 1 minus alpha ka whole ki power 4 is basically equal to 4. Now from here if I solve I will get alpha by 1 minus alpha ka whole square is basically equal to plus minus 2, is basically equal to plus minus 2. Now from here if I solve this particular result, that will I will get, if for plus 2 if I solve I will get the result as 2 into 1 minus 2 alpha plus alpha square. Now if I solve this I will get 2 alpha square minus of 5 alpha plus 2 is basically equal to 0. So from here I will get the summation of alpha I is basically equal to 5 by 2. Now for this is the first result, and for second result if I solve, that's basically alpha square is basically equal to minus of 2 times of 1 minus alpha square. So this result, can it be possible? No, this can never be possible for alpha belonging to real number minus 1 and 1. For this particular element, this particular choice of this particular set of elements, this alpha square can never be equal to some negative number. So this is not possible. So from here we get only the one result, that is alpha summation of all possible values of alpha. The summation of all possible values, which is actually asked in the question, the sum of all possible values of alpha will basically equal to 5 by 2. With this we get the right answer to this question is option number D. I hope this particular solution was clear. So with this we solved the fifth question, and let us move on to solve the sixth number question. Okay, so what we see in this particular question, again we got a question where I actually have to deal with a system of linear equation. Now what this solution says, this is a homogeneous system of linear equation, and it has says the non-trivial solution. I always explain that trivial का मतलब होता है unique, and unique solution corresponding to homogeneous equation तभी हो सकता है जब डेल्टा का वैल्यू नॉन जीरो, और नॉन ट्रिवियल वैल्यू corresponding to नॉन होमोजेनियस इक्वेशन तभी हो सकता है जब डेल्टा का वैल्यू क्या हो जाए, जीरो हो जाए. So let us solve and equate the delta value as 0. So delta value is 0, that means the value of this determinant of the coefficient matrix is equal to 0. Let us solve this and get to the result. This will be 1 minus 1, 1. This is 1 tan theta over here. This will be 1. This will be root 3. This will be root 7. This will be tan theta. This will be tan theta. So this will be tan theta, and if I equate it to 0, from here I apply some elementary row transformation, that is row 1 goes to row 1 plus row 2. Similarly row 3 goes to row 2 goes to row 1 plus row 2, and row 3 goes to row 1 minus of row 3 minus of row 1. So from here I will get the result, to this particular question as I will get the result of this particular question as 1 over here, 0 over here, and 0 over here. Similarly 1, and this will be tan theta plus 1. This will be 1. This will be basically minus, so this will be again 0. From here I will get root 7 plus of root 3, and this will be tan theta minus of root 3, and its determinant is equal to 0. So from here if I solve this particular determinant value, okay. So from here if I solve the determinant value, I will get the determinant value as tan theta plus 1 multiplied by tan theta minus of root 3, which is equal to 0. So from here I will get two equations, that is tan theta correspond to minus 1, that and the theta value is ranging from minus pi to pi. Both values are inclusive. So for this I will get theta का value जो होने वाला, that is minus of pi by 4, and I will also get the theta as 3 pi by 4. So for this particular theta is the summation of theta's part form is basically equal to pi by 2. And again if I solve this particular equation in the next page, if I solve another equation, that is tan theta corresponding to root 3, I will get the value of theta basically equal to pi by 3, and I will also get the value of theta is equal to minus of 2 pi by 3. So for this if I perform the sigma theta, I will get the value as minus pi by 3. So all the corresponding results, if I sum of all the thetas that I will get as pi by 2 minus of pi by 3. So for here I will get the result as pi by 6, and for the question we are actually supposed to calculate 120 by pi into sigma of I1 to like at n, where theta phi all the possible solution, sum of all the possible solution of theta. So from here if I solve this particular result, I will get the value, okay. So from here I will get the value as pi by multiply pi by 6, if pi is pi cancel and 6 get cancelled by 20. So from here I will get the result, that is actually equal to 20. So with this I come to the correct answer to the question, that is basically option number D. Okay, so I hope this particular solution is clear. Now this is basically very useful and simple question. आप JEE में क्या करेगा ना, आपको मैट्रिक्स डिटरमिनेंट के कॉन्सेप्ट के साथ साथ आपको ट्रिग्नोमेट्रिक इक्वेशन का क्वेश्चन भी घुसा दिया, ठीक है. I hope this particular solution is clear. Let us move on to the solving the seventh question. Now if you see this particular question, you have already seen this type of question in the lecture of the matrix and determinant. Okay. Now this type of question I have already talked about. Now by looking at this particular question, you should be very happy. Now when I was discussing the IIT JEE previous year question of 2005. Okay. Now from this particular thing, if I see the matrix P, which is given as root 3 by 2, similarly 1 by 2, 1 minus 1 by 2, root 3 by 2 over here. Now if I see and check out the values of A1 plus A2 ka whole square is equal to 1. And similarly if I check b1 square plus b2 square, which is also equal to 1, and similarly if I perform a1 and b1 plus and add it to A2 plus B2, I will get 0. So this directly applies what? The condition of orthogonal matrix. This directly applies the condition of orthogonal matrix. If you want to check orthogonal matrix, this is a shortcut which I already mentioned in my lectures, or also you can check this as P into P transpose is basically identity matrix, which is also equal to P transpose into P. If you compute the result, you will get identity matrix only. So if you want to compute, you can compute. I don't want to see over here because I know the shortcut. Okay. Now again, if I see the result, that is Q, that is P into A into P transpose. Now what is actually mentioned in the question is actually have to calculate to go on to solve the power of Q power 2007. Now if I try and write in form of this particular thing and multiply it 2007 number of times, that is I will get the result, and this is actually 2007 number of times. Okay. Now from here what I see is basically this particular same things. Okay, P transpose into P transpose into P over here, and similarly P transpose into P over here. So this particular result will directly give me the result, that is basically P into A ki power 2007 into P transpose. Okay, so I hope this particular thing is clear. And when I see that the question mentioned as P transpose into Q ki power 2007 into P is basically equal to 1 A, B, C and D over here. So from here if I see this particular value will be directly equal to 2000 power 7, A ki power 2007. So from here I will get this, because if you see the Q ki power 2007 is basically equal to P into A ki power 2007 into P transpose, and if I multiply P transpose here and P over here, I will multiply P transpose and P over here. So this particular thing will be an identity matrix, this particular thing will be identity matrix, and we are left with A ki power 2007. So from here I will get A ki power 2007, because this particular Q ki power 2007 is basically P into A ki power 2007 into P transpose. Now if I solve this result, and again I have to check. Now A matrix is also given same a very easy matrix for us. अब A का जो मैट्रिक्स रखा है, this is a triangular matrix, which is an upper triangular matrix. अब मैंने already बता रखा है, जब भी we are performing some product of matrix, upper triangular matrix always plays an advantage कि higher products use नहीं करना पड़ेगा. And if you go and compute the higher products, which I have already calculated myself, if you see this product, that these elements remains unchanged, this element changes. So अगर A cube भी calculate करते हो ना, this will be basically 1, 3, 0 and 1. So similarly, if you see that जब n का value यहाँ पर आने वाला है, that is value seen here. So if I write A ki power n is basically 1, n, 0 and 1 over here. So from here I will get A ki power 2007 is basically equal to A, B and C over D over here is equal to 1, 2007, okay, 2007, 1 and 0 over here. Now from the question that is actually asked to calculate the 2A plus B minus of 3C minus of 4D, that is 2A plus B minus of 3C minus of 4D minus of 3C minus of 4D. So from here if I calculate the result, from I will get 2 plus 2007 minus 0 minus of 4. From here I will get the result as minus of 2, that is 2005. 2007 minus 2, that is 2005. So from here I get the right answer to this question as 2005, which is the year in the ITJ question actually asked this particular type of question. Okay, so I hope this particular solution is clear. From this the answer is option number D. So with this we come to the end of the 7th question, and let us move on and try to solve the 8th question. And this particular 8th question is also a very important question that if you try to encounter, कि आपको देख के समझ में नहीं आएगा कि कैसे करना है, but if you move on and try to compute the in terms of variable terms, you will directly get to the result. So from here we are given a matrix condition, that is A square is basically an identity matrix. So from here if you calculate the determinant of both the side, you will get determinant of A ka whole square by is equal to determinant of A. So from here, and it says the determinant value of A is basically equal to B, that is B square is equal to 1. So from here I will get the B square का value तो 1 मिल गया. Okay, and again if I assume the matrix A as A, B, C and D over here, and if I compute this A square value, that is basically A, B, C and D, and if I multiply A, B and C and D over here, and I compute this result, that I will get here it is A square plus B into C. And similarly I don't care with this particular elements, or if I want to take care of this particular elements, okay, this particular element that is a non-diagonal element, that is A, and if you multiply this is AB plus BD. Similarly this particular element will be CA plus DC. Similarly this element will be D square plus BC. Now from here what I see that A square is basically equal to identity matrix, so there is 0, 1, 0, 0, 1. So from here I'll get A square plus BC is equal to 1. Now if I see, and again I get AB plus BD is equal to 0. So from here I will get A plus D times b is basically equal to 0. Now we know that all the elements, all the corresponding elements that is actually mentioned in the question, that कोई भी elements is non-zero, मतलब b का वैल्यू 0 नहीं हो सकता है. So what can be the implication from this condition, that a plus d का वैल्यू 0 हो सकता है. So from here I get that अगर अब मेरे को पूछा जाए कि what is the trace of a, I will say that is equal to 0 because trace of a is basically equal to a plus d. So in this question it says the sum of the diagonal elements is basically equal to trace of the element. The sum of the diagonal elements, sum of all the diagonal elements of a is basically trace, and that is actually small a. The small a का वैल्यू कितना हो गया, a is 0. So if I compute this result, a square plus 4 times of b square, what will the result I will get? I will get it 4. So with this the correct answer to this question is option number A. So I hope this particular very simple question, very easy question as well. Okay. Now let us move on and solve the ninth question. So if you see this particular question, then this particular question is very tricky question. Okay, this question is very tricky question. Now if you try and compute the results from this particular matrix equation that is given as p square is basically equal to identity minus p. Okay, now the question mentioned that p ki power alpha plus p ki power gamma beta is equal to gamma times identity matrix minus 29 times p, and similarly another equation is mentioned over here. So from this particular equation actually we need to get to the result, but ये equation से कुछ फर्क नहीं पड़ रहा कि कैसे को इस question को solve करें. So from here if I compute the higher power of this p matrix to get the alpha या फिर beta and then compare the results, then we get to the actually the answer to this question. Okay, and this is delta times of identity matrix minus 13 times of p. Now these two equations are given in the question. Now let us solve taking higher powers और p square, जो p square is equal to identity matrix minus p दे रखा है ना, इसको अगर मैं p से मल्टीप्लाई करता हूँ, that is pq is basically p minus p square. Now p square का वैल्यू ऑलरेडी दे रखा है, that is p1 minus identity matrix minus p. So from here I will get the value is 2 times of p minus identity matrix. Now similarly if I compute the result for p4, I will get 2 p square minus identity matrix minus matrix p, which is equal to 2 times of identity matrix minus 3 times of p matrix. Now similarly if I go on and solve the result for p ki power 5, I will get the result as 2 times of p minus 3 times of p square. So from here I will get 5 times of p square is basically 5 times of p minus 3 times of identity matrix. So from here I will get 3 times of identity matrix. Okay, 3 times of identity matrix. So if I compute again p ki power 6, I will get there is 5p square minus 3p. Now if I compute this result, I will get 5 identity matrix minus times of 8 times of p matrix. Now let us label this result as option of equation number A. And let us, if I solve again, go on and solving p ki power 7, I will get how much? This will basically equal to 5 times of p minus of 8 times of p square. Okay, so from here if I solve this result, I will get p minus of, this will basically 8 identity matrix and 13 times of p, okay, because minus of minus 8, that is plus of 8 plus 5, that is 13 times of p. So if I again compute p ki power 8, I will get 13 p square minus of 8 times of p, which is equal to 13 identity matrix minus, this will be 21 times of p. Now if I label this number as b, and what I see is basically if I add p ki power 8 plus p ki power 6, what I get the result? I will get the result as minus of 29 times of p and plus of 18 times of identity matrix. Now if I compare the result from the equation number 1, what I see over here is p ki power alpha plus p ki power beta is basically something that is gamma identity matrix minus 29 times of p. So from here also I get 29 times of p. Now similarly if I go on and compute the result, that is p ki power 8 minus p ki power 6. From here I will get this is basically 5 and 13 minus 5, this is basically equal to 8. 13 minus 5, this is 5. Okay, minus 13 times of p, this is 21 minus of 8, basically equal to 13. So from here if I look at option number 2 over here, we also get this particular result as p ki power 8 minus p ki power 6, which similarly looks to p ki power alpha minus p ki power beta, which is equal to minus 13 over here, and this is 5 over here, and this result similarly looks to p ki power alpha plus p ki power beta, that particular question. So from here what I can say कि alpha का value 8 है, beta का value is basically 6 है, and gamma का value is basically 18, and delta का value is basically 5. Okay, so from here I get the unknown values like this way. If I compute the continued product, we'll get like the values same. Okay, now if I compute the result that is actually asked in the question, that is basically the result which is asked in the question is basically equal to alpha plus beta plus gamma minus of delta. So alpha plus beta is equal to 14, 14 plus 18 basically equal to 14 plus 18 basically equal to 32. 14 plus 18 is basically equal to 32. This will basically equal to 32 minus, and delta value is 4. Okay, if we solve this, the delta value was basically equal to 4. Delta value is equal to 4 because over here it will be 4. 13 minus of 8. This will be basically 4 over here. Okay. And let me check again. Okay, this is actually 5, right? So 13, and this is basically, and this result is 13. 13 minus 5. How much it is? It is 8. Okay. This is 8. This is 8. Okay. What am I doing? Okay. So sorry for the mistake. Okay. Now if I 32 minus 8 is performed over here, if 32 minus 8 is performed over here, if 32 minus 8 is performed over here, I get the result as 24, which is the right answer to this question. That is option number C. I hope this particular solution was clear by taking the continued product. Now this type of question also comes very tricky in examination, where you don't get any idea कि start कैसे करना है, कहाँ से start करे, कहाँ को end करे, पता नहीं चलता. But if you compute the higher powers and you get and relate the particular equation results given in the question, then you get the solution. So this is a star mark question. Okay, so star mark this question as important. Okay, star mark this question as important question. I hope this particular solution is clear. And let us move on to the. So with this we come to the. I hope I have covered all those questions. Okay. So with this we come to the end of the lecture. Okay. So this particular question is basically the homework question that I want all of you to try. This particular question is basically the homework question that I want all of you to try. Okay. This is a homework question. Try this homework question by yourself. Okay, try this homework question by yourself, where matrix A is given, and basically this particular result is actually calculated in form of determinant. So I hope this particular question comes very handy, and if you are able to solve the question and you are able to get to the result, okay, do mention in the comment section. Comment section में आंसर बताओ क्वेश्चन का आंसर क्या है. मैं क्वेश्चन का सॉल्यूशन लेने वाला हूँ नेक्स्ट पर्टिकुलर लेक्चर में, ठीक है. बट आई वांट यू ऑल ऑफ यू टू ट्राई दिस क्वेश्चन. इफ यू आर एबल टू ट्राई दिस क्वेश्चन एंड गेट टू द रिजल्ट, इससे बढ़िया चीज़ कुछ नहीं हो सकता है. जहाँ पर आप क्वेश्चन खुद से सॉल्व कर रहे हो एंड यू गेटिंग द रिजल्ट, ठीक है. सो आई होप यू विल ट्राई ऑल दिस क्वेश्चन ऑन योर ओन. आई होप दिस क्वेश्चन यू विल ट्राई दिस क्वेश्चन ऑन योर ओन एंड गेट टू द रिजल्ट, ठीक है. आई एम नॉट मेंशनिंग द आंसर क्या है क्वेश्चन का, ठीक है, बट ट्राई दिस क्वेश्चन ऑन योर ओन एंड मेंशन द आंसर इन द कमेंट सेक्शन. ऑल्सो मेंशन योर स्टेप्स, लाइक हाउ यू अप्रोच दिस पर्टिकुलर क्वेश्चन. Okay, so with this I come to the end of the lecture. That means the JEE Mains previous question. I have taken up the most top 10 important question and I given one question for you to solve. Okay, so I will take up more JEE Mains question of matrices and determinant in the upcoming lecture as well, and similarly I will move on with the questions of JEE Advanced in the upcoming lecture. और JEE Mains का जो क्वेश्चन बैंक मिलेगा वो डिस्क्रिप्शन बॉक्स में मेंशन हो जाएगा, ठीक है. सो डाउनलोड इट फ्रॉम द डिस्क्रिप्शन बॉक्स एंड शॉर्ट नोट्स ऑफ द मैट्रिक्स एंड डिटरमिनेंट चैप्टर दैट विल प्रोवाइडेड इन फॉर्म ऑफ अ वीडियो in the coming shorts. Okay, in the coming lectures also I will be providing that particular short notes in form of a short video. Okay, so that you can download the short video from the description box and try revising the chapter of matrices and determinant from the particular short notes. So with this I come to the end of the lecture, and I hope you like the lecture and appreciate my content. With this, thank you.